In our second example, we're going to work on using common parts of triangles. Our question is angle EGD congruent to angle EFH? So let's look at our figure and find those angles. Angle EGD, so that means the vertex is at G. So go from E to G to D. So that's this angle right here at G on this side. Is that congruent to angle EFH? F is the vertex, so your angle is at F. EFH, so this right here. So are these two angles congruent to each other? We can think through triangles to answer this question. So angle EGD, if I were to outline that angle, here's angle EGD. I can see that I just have to connect over here. Now I have triangle EGD. I'm going to switch colors and identify the other angle and see if it's also part of a triangle. EFH, so E to F to H. All right, so there's our second triangle. If I were to redraw those separately, just so we can be super clear what we're looking at. So I'm going to separate them out. Here's D, E, G. And then the other one is something like this, E, F, H. We have some congruencies that we'll want to fill in our picture. We know that DE is congruent to EH, and we know, okay, let's see what else we know. So we have a congruency mark right here. This is on DF. We have a congruency mark right here, which is on HDG. So this overlap right here is part of both triangles. So if I were to write this out, well, I'm going to write this out. We have DF plus FG giving us this whole thing of DG. That is part of, DG. That's the side of this triangle, DG. All right, well, we also have in the other triangle, HG. So here's H to G plus G to F is equal to the whole thing HF. And HF is part of this triangle right here. All right, so what we notice, this is the angle addition postulate, by the way, that lets us say the two small segments add up to the big segment, and the two small segments add up to the big segment. If we notice that I forgot to put on my segment lines, there we go. We have this as part of both sides. So DF plus FG and HG plus GF, we're adding on the same segment to congruent segments. Those are congruent, DF and HD. Therefore, these must be congruent. HG, that's not an HG. DG is congruent to HF. So let's go ahead and mark that in the picture. We just said DG was congruent to HF. Okay, so the next thing we want to look at, sometimes you'll find that going back to the original big picture, I'm going to erase just a little of this just to get out of my way. Going back to the original big picture can be helpful, or looking at your two overlapping triangles separate can be helpful. If I look at the big triangle, so now I have triangle DEH, this big triangle, do you notice how we have two congruent sides? Well, if you have two congruent sides, that makes, let's write it off to the side, triangle DEH is isosceles. When you have an isosceles triangle with two congruent sides, that means that those base angles will be congruent. So the angles opposite each of those sides will be congruent. So we're going to mark this angle H congruent to this angle D. So angle H is congruent to angle D. Now I notice we have congruent triangles. We have two sides in the included angle, two sides in the included angle, so we can state that triangle DEG is congruent to triangle HEF. All right, well, when you have congruent triangles, that means all the corresponding parts are congruent. We want to know is EGD, and again, where is EGD? Is this angle right there? Is that congruent to EFG? Well, those angles are corresponding, so I would say yes. Angle EGD is congruent to angle EFH by CPCTC.